Welcome back to Visualization for Sense Making. We're now jumping into Module 2. We're going to work on work domain analysis, which is an analysis method to help us get a kind of a jump start into understanding a new world so that we then know how to visualize it. So before we get into what work domain analysis is, let's talk about why we're taking what might look like an enormous departure from visualization to start thinking about this thing that feels a little bit different than what we just did in the last module. So traditionally, when we ask folks that do data visualizations for a living how they do their work, or how they know they've done it right, or how they know that they're done, they kind of just scratch their heads, and what they describe is something kind of like this: that they go seek out this referent domain knowledge, just something in the domain. They figure out what's important, and then they send that into their design process. And just so you know, this is the design process right here. So they send that into their design process, and it goes in there, and kind of kicks around, and it churns, and then out pops out a fully designed representation that looks kind of like this. It just kind of comes out the other side, and it's really unclear how we got there. So our next approach, at least here at Ohio State, was to try to come up with some do's and some don'ts with data visualization. We're trying to represent a dynamic world. And they're not quite don'ts, they're the finesses. So again, these finesses are strategies that are sometimes powerful but can often get us in trouble because they're doing the following things. One, you can reduce available data, or you can do a global static reduction, which is you can make some rules at the beginning when you design it, and then the machine will take those rules and separate out and only give you what's important. Or it could be more dynamic, which we call intelligent agent selection, where a machine dynamically decides at that point. And then 4, syntactic, much like 3, but the machine uses more statistical methods to try to figure out what's important. And with these finesses, we're just trying to caution away from those, especially in dynamic worlds, because the machine or the person that's filtering out those data could inadvertently filter out important data. So then we created these rules to escape from data overload. And when I say we, I mean Dave Woods. And so these are the rules. We want to use organization first to precede selectivity. We want to use positive selectivity, which is enhancing a portion of the visual field, as opposed to negative selectivity, which we're taking a portion away. We have to deal with context sensitivity. We firmly believe that observability is more than just data availability. And then the last, we want to make sure that we're setting up powerful frames of reference, and that these computational techniques, the finesses, are used in these secondary ways. So this, to this point, should be just a review of some of the things we learned in Module 1. And then we got a little bit more pragmatic or practical. And we said these are the 4 basic techniques. So don't think about just that black hole of an amorphous process. Here are your basic techniques. You want to discover frames of reference. You want to put the data in context. You want to highlight change in events, which is a positive selectivity, and you highlight contrast from the norm. So how is this different than the norm, or how are we marking out some kind of boundary conditions and how close we are to those boundary conditions? And this was our first shot at what this design course needed to be and what designers really needed to make these visualizations. What we found over the years, though, is that wasn't enough for some students. In fact, for most students. So if a student came in and already done quite a bit of design in general or visualization specifically, then this new thinking about finesses kind of put them in this new gear. But for students who were not as familiar, they needed a lot more scaffolding. And we chose work domain analysis to be that kind of scaffolding, or those small steps to get us to a much bigger concepts, which actually you'll get into in the next modules. So really what we want to do is provide a framework so that we could go into a new setting and understand all of the important concepts and variables that we'll need for our later design work. We also want to provide a set of steps if you get stuck. And then third, to provide a method to identify gaps in the understanding of the system. The system doesn't tell you when you're doing analysis, hey, look over here or look over there. Hey, you might have missed this. We need a method to help us understand those kinds of things. And just for your reference, work domain analysis, it goes hand in hand with ecological interface design. And that basically, ecological interface design is a method or set of methods so that we can create relationships in the representations that we build that are going to correspond to the relationships that exist in the referent or in the world. We're going to build those structures in our representations, in our visualizations, to match the structures in the world. So we've replaced that black hole. Remember, it used to sit right about here and used to go straight from referent domain knowledge to design representation. And instead, we're going to go from kind of loose referent domain knowledge. We're going to build a work domain out of that. Then from that work domain, we're going to determine or discover what the relevant variables are, what their constraints are or boundary conditions, what relationships that they have to each other, and from there we can construct our frame of reference. From that frame of reference and from these variables, constraints, and relationships, we can choose adequate or appropriate visual forms, and those visual forms together will build out our designed representation. The first thing we're going to do for work domain analysis is introduce the concept of a system boundary. We're actually going to put basically a border or a boundary around the system that we care about or that we're going to target, and then we'll also talk about the abstraction hierarchy. The very first thing we have to do before we get really into the details of our work domain analysis is figure out what's the most appropriate scope for us to start, and usually that's determined by the series of questions that we want to answer. So we may be asking questions that would require us to really look at the entire system. So what we're looking at here is a hospital. And so maybe we're going to look at the entire system, and now we're looking at maybe total profitability or total costs or morbidities and mortalities across the entire unit. What are, generally speaking, patient outcomes or safety outcomes? So maybe it really is important to look at the whole hospital. Or maybe we're going to take a closer look, and we're going to look just at the pharmacy. We just care about the pharmacy. Now the pharmacy is going to have inputs and outputs direct to the other parts of the hospital, but really we could say that the system is the pharmacy itself. Or maybe it's much more important to think about one of the clinical floors, and how that works, so cardiology or the x-rays, or how that gets into the more of the inpatient parts of the hospital. Again, that's, you're going to look at very different things. Maybe you're talking about tool utilization or patient outcomes just in that unit, or maybe you're looking at a cross-section across, or maybe instead of cardiology you really want to look at neonatology, and so you're looking at different patient population. You would look at your patients differently. All of those different scopings are going to give you a very different perspective of what you should be looking for and what the appropriate data relationships are. So once you've determined your scoping, or at least your initial scoping, you can always change your mind later. We're going to abstract out the different concepts of the system, or the different parts of the system, with these 5 levels. Now these 5 levels were developed for industrial systems. So those are systems that can be described easily with more physical science type of measures, and we'll see how that plays out as we go on through the lesson. But generally speaking, we're going to start with a functional purpose, and that's really the goal. What was this work domain designed to do? What are the different goals? From there, we're going to go to abstract function, which are one of the underlying laws or principles that are at work and that make that system go. From abstract function, we go to generalized function. What are the processes that are involved? So we're starting to think about actions that happen. What are the things that people and processes and technologies need to do in order to meet those goals, in order that comply to those laws, but you kind of make them run. From generalized function, we get into physical function, and there's actually kind of a really nice line we can draw right here, where below this line we're really looking at the physical parts. These are the things you can see in the system, and up here we're really thinking about kind of the more abstract parts, and how do those physical parts work together, and that includes people, that includes equipment, it includes all the components of the system. And what we want to do is be able to kind of tease back and forth between these things to say, what's going on down here below the line, and then what are the processes that we need to be able to enable above the line. Now, like I said, the original abstraction hierarchy that you saw on the last slide was designed for more industrial systems or physical systems, manufacturing, processing, chemical plants, those kinds of larger industrial processes. And so a lot of the laws and a lot of the goals, a lot of the processes can be thought of in terms of physical science processes. When we think about more social systems or socio-technical systems, we can use more general language on these top three levels. And again, just like before, we have this kind of line here where below it is the physical stuff, above is the abstract stuff. You'll see that those last two, physical function and physical form, stay basically the same. The names of these top three get generalized. And so instead of functional purpose, we're just looking at goals. Again, we have the same words here to describe them, but maybe a different label is appropriate. So we think about goals. What are the goals of that system? What are the balances and laws? And with this, I like to think about what are the things that we want to transform, and what are the things that we want to stay in relative homeostasis? What are the things we want to stay still? So, for example, for a university, we want to increase knowledge and learning of the graduates. There are also some things that we'd like to remain, relatively still. We'd love to get costs to go down, but it's okay if costs stay relatively the same. Same thing with if you think about the human body, we want a lot of the physiological processes. It's fine if they just kind of stay where they are, but there are a lot of other parts of the body, like say you're trying to lose weight or you're trying to increase strength. Those are things that we want to transform or change. And then down into processes, again, thinking about the actionable words, and this is running and jumping and those kind of things, translation and communication and coordination, all of those things sit in the processes layer. So in the next two videos, we'll take a deeper dive down into these 5 levels to give you examples of how these work in different systems and actually start to build out an abstraction hierarchy.